Okay, so in this section, we're going to learn about gas forming reaction with a weak acid. So in the previous section, we learned about acid-base reaction that involves strong acid and a strong base. Now let's see how we write the molecular total ionic and ionic equation, net ionic equation for a weak acid. Okay, remember weak acids do not dissociate 100% to ions. Most of it going to remain as the weak acid itself. Okay, so we have here sodium hydrogen carbonate as our base and acetic acid as a weak acid. Together going to form a so together going to form the product sodium acetate and carbon dioxide and water. Okay, basically if you look at this reaction, if I rewrite it, so we have sodium hydrogen carbonate plus acetic acid CH3COOH. Acetic acid, the ions that it is going to have is acetate ion and H plus. So this is the hydrogen that act as an acid. And in sodium bicarbonate, the two ions are sodium ions and bicarbonate is same as hydrogen carbonate. Now when this is going to form the product, it's going to form sodium ion going to combine with this acetate. So then it would be CH3COO, sodium acetate. And then with this hydrogen H plus going to combine with hydrogen carbonate. So H plus and HCO3 minus will make it H2CO3. So this is carbonic acid. But you don't see that carbonic acid as one of our products because carbonic acid is a very weak acid. As soon as it forms, it's going to decompose, it's going to break down to carbon dioxide and water. Okay, so that's what you are seeing here. This is one of the product, sodium acetate, and then the other two are carbon dioxide and water. So that's going to be your molecular equation. So the total ionic equation, sodium hydrogen carbonate dissociate into sodium ions and hydrogen carbonate. But you can see here the acetic acid is not going to break into ions because it's a weak acid and it's going to stay intact most of the acetic acid. Okay, and we are not going to put them into ions in your molecular total ionic equation. It's going to stay as the weak acid. And then the sodium acetate, its ionic compound sodium ion and the polyatomic ion acetate, it's going to separate into its ions and then carbon dioxide and water. Now what are the spectate ions we have here? So we always find the spectate ions from the total ionic equation. So we have sodium ions, you have sodium ions. Anything else? No. So then the net ionic equation would be whatever left. Hydrogen carbonate, acetic acid, forming acetate ion, carbon dioxide and water. That's how we write molecular total ionic and net ionic equation if a reaction happening with a weak acid. Write balanced total and net ionic equation for the following. Hydroiodic acid. Hydroiodic acid is Hi, which is a strong acid, and calcium hydroxide. Calcium hydroxide is CaOH2. Calcium is +2, hydroxide is -1. So this is a proper formula, and both of these are a strong acid and a strong base. So what are the products we're going to form? We're going to form calcium iodide, CaI2, because calcium +2, iodide -1, and then a water molecule. Now let's see if we need to balance this. There are two iodide on the product side, so you need to put 2 there. So 2H plus, 2H plus, so 4. So you have to put 2 there. 2 2 oxygen. Now it is balanced. Okay. Now calcium iodide. So since this is acid-base reaction, liquid water is going to form, and that's going to be one of the products. And we need to also find out if a calcium iodide is soluble or insoluble. So you can refer it to the chart to find out whether calcium iodide is soluble or insoluble, and you will know that the calcium iodide is in soluble. Okay, calcium iodide also soluble. So this is going to be AQ, AQ, AQ. Okay, so that's going to be your molecular equation, and then the total ionic equation. So the total ionic equation going to be, since it's a strong acid and a strong base, so you can write what are the reactants: hydroiodic acid and calcium hydroxide. So hydroiodic acid, HI, 2H plus 2I minus plus calcium hydroxide, calcium 2 plus 2OH minus, all of these are AQ, and then the products are going to be calcium iodide, calcium 2 plus 2I minus, AQ plus the liquid water. Okay, so what are the spectate ions? Your spectate ions are going to be 2I minus, calcium 2 plus, calcium 2 plus. So those are the spectate ions, and your net ionic equation would be 2H plus 2 hydroxide, giving you 2 water molecules, OH plus OH minus, giving you a liquid water, like that. Okay, so this is how you would write the acid-base reaction for a strong acid and a strong base. We already covered that in the previous section also. Now the next one, potassium hydroxide and propionic acid. Here the propionic acid is a weak acid. How do you know it's a weak acid? You guys don't know what is the structure of propionic acid and what it is. But one thing for sure is you know that this is not one of the strong acids. Remember the strong acids? They are your hydrochloric acid, hydrobromic acid, hydroiodic acid, sulfuric acid, nitric acid, and perchloric acid. So those were the strong acids. So this is not one of those. So then you know this has to be a weak acid. Okay. Now let's gonna go ahead and write the potassium hydroxide and propionic acid. So potassium hydroxide. Potassium hydroxide is KOH. Propionic acid is similar to acetic acid. Now acetic acid is this acid with one CH3 group. Propionic acid is, instead of CH3 here, you will have another CH3 and this would become CH2. So that's a propionic acid. Again, the acidic hydrogen going to be this hydrogen. So it's going to form the product potassium propionate, CH3, CH2, COOK, potassium propionate plus the water. Water is going to form between this oxygen, hydrogen, and this one, forms the water. Okay, that's the molecular equation. All of these are aqueous, soluble in water. So this is the molecular equation I just wrote, and then total ionic equation would be potassium hydroxide going to break into ion K plus OH minus, and since propionic acid is a weak acid, you do not break it into ions. You're going to keep it as propionic acid. And then from this side, it can be broken into potassium ions and propionate ion plus the water, liquid water. So what are our spectate ions? It's going to be K plus here, K plus here. K plus is the only spectate ion, and for the net ionic equation you have propionic acid and hydroxide forming propionate ion and liquid water. That is with a weak acid and a strong base. Okay. Okay, so let's stop here before we go to the acid-base titrations.